underlined in red should take you to directly to that website or to that document. Okay, so let's talk a little bit now about fire retardants and truss design. Fire retardant treatments are typically applied to building materials such as dimension lumber, and then many times you'll see that then referred to as fire-retardant-treated wood, and plywood to reduce the ability of the wood to fuel a fire. This treatment can allow FRT materials to be used as an acceptable alternative for building code requirements that specify non-combustible materials in specific applications. Now, I want to make sure everybody understands, however, that FRTs do not make the wood non-combustible, at least from the definition that's used by the building code. However, what they do is they definitely, or they greatly reduce the ability or the flammability of the treated wood, thereby limiting its contribution to the growth of the fire. In fact, FRTs actually, they lower the temperature of combustion for the wood. And what that does is then the wood will quickly form a charred layer, and that charring acts as sort of like an insulator, and it greatly slows down the rate of combustion of the wood. So the FRTs actually reduce the temperature of combustion, and wood chars faster, and then that slows down the rate of combustion. So while reducing the flammability of the wood, the fire retardant treatments may also cause degradation of the structural properties of the wood, which needs to be taken care of or considered in the design. Depending upon the type of treatment that's used, FRTs may require a reduction in the design values of the wood materials, a reduction of the capacity of the fasteners and connectors that are used to attach the wood materials. For trusses, that would be the connector plates, and in some instances or applications it may also require additional protection for the fasteners and the connectors. So that's why it's fairly important to know what type of fire retardant treatment is being specified, and then how to use that in the design of whether it's trusses, I-joists, whatever. Code requirements related to the fire retardant treated wood are located in two places in the International Building Code. Chapter 6 basically details the various occupancies and construction types that allow the use of fire retardant treated wood. And again, some of the non-combustible application or construction types, such as type 1 and type 2, there are instances that fire retardant treated wood is allowed to be used, and we're not going to get into those various instances during this presentation. But then also chapter 23, which is typically the chapter on wood design in the IBC, this is where you'll find information in terms of what the requirements are for FRT, the labeling requirements, design, the reduction requirements, and so on and so forth. And we'll spend a little bit of time now looking at those. So section 2303.2, fire retardant treated wood section, has several subsections. 2.1 discusses if the fire retardant treatment is a pressure process where the wood is basically, the wood materials are put in a cylinder, and they're, through pressure, the treatment is impregnated into the wood. 2.2 it includes other means during the manufacture of the product. So not just pressure impregnated, there are maybe other means that are allowed. 2.3 talks about the type of testing that's required if it's an other means during manufacture. So 2.3 and 2.2 go hand in hand. Section 2.4, 2303.2.4 discusses the labeling requirements that each piece of wood has to have on it, so that those using it can understand what the treatment is and how it's to be used, or how the product is to be used. 2.5 talks about the strength adjustments. Subsection 5.1 talks about the strength adjustments for wood structural panels, and 5.2 would be for lumber. 2.6 basically talks about exposure to weather, damp or wet conditions, and this would be typically exterior applications. 2.7 talks about the requirements for labeling it as for interior applications. And then 2.8 talks about what the maximum moisture content for the product is after the treatment has been applied. And then 2.9 refers you to the type 1 and 2 construction applications. So fire retardant treated wood is defined in the code then as has to have a listed flame spread index of 25 or less when tested in accordance with an ASTM standard E84 or UL 723. And again, this index basically is measuring the burn characteristics of the particular product and how quickly the product burns and how quickly that flame propagates along the surface of that product. And in this case, a spread index of 25 or less is termed Class A, and that's typically what you're going to see with fire retardant treated wood products. I think the best I've seen for a non-treated wood product is 35, which would be a Class B. And there are several different untreated wood products that meet those requirements. But again, the code would say that, okay, if you want to use this product in this application, it's got to be a Class A flame spread. So that's typically going to be a fire retardant treated wood product. In addition, and that's a 10-minute test basically, they measure the propagation of the flame spread. An additional requirement is that it has to show no evidence of significant progressive combustion when the test is continued for an additional 20-minute period. And this would basically typically has to mean, or it means is basically the flame front cannot progress more than 10.5 feet beyond the center line of the burners at any time during the 30-minute test. Okay, labeling. A lot of information is supposed to be on the label, and again, that helps the end user know exactly if they've got the right product or if the right product is being used. Some of the things that need to be on the label would include the identification mark and of an approved agency. And in this case, that approved agency would be Underwriters Laboratory in the example I'm showing here. Identification of the treating manufacturer, this is Hoover, as you can see. The name of the fire retardant treatment, it's their PyroGuard. The species of wood that's being treated, in this case it's southern yellow pine or southern pine. In this case, another information would be flame spread and smoke development index. Flame spread is 10. Remember, we need to have at least no more than 25. So this flame spread in this case for this product certainly meets those requirements. Smoke development in this case is 20 to 50. And these all numbers, depending on the code and the application, will determine if you can use this product in those applications. The method of drying after treatment, that can be very critical. In this case, it's really hard to tell, but this was, you can see here, KDAT and kiln dried after treatment. And then conformance with the appropriate standard in accordance with 2303.25 and 2303.2.8. In this case, they have, this is an older label, NER, there's an NER report for this product, NER 457, and that would be a code evaluation report through it would now be an ICC evaluation report that you would go and take a look at that, and that will give you much more information about this treatment and what the strength properties are and how the strength properties were produced. And then finally, if this product were to be used in applications that are exposed to weather, damp, or wet locations, it needs to include the phrase, no increase in listed classification when subjected to the standard rain test, ASTM D2898. Again, that would be for an exterior application. In this case, this doesn't have that on there. So in looking at it, one would assume, and rightfully so, that we are looking at a interior application only. Okay. Now, section 2.5, strength adjustments. The design values for untreated lumber and wood structural panels would be adjusted for the fire-retardant treated wood. These adjustments to the design values have to be based on approved methods that take into consideration the effects of the anticipated temperature and humidity to which the FRTW will be subjected, the type of treatment, and the redrying procedures. And then the code lists a whole bunch of standards, and we're not going to go through it, but just know that the treating company would use these standards to develop the adjustment factors that they then publish so that the end user, whether that's the building designer or the truss designer, would then apply those reductions to the various properties of the wood and of the connections. Another thing that's critical with FRT is that the fire-retardant treated wood needs to be dried to a moisture content of 19% or less for lumber, and wood structural panels 15% or less after they've been treated. Many of these are water-based, or I believe they're all water-based, and so then the product has to be redried down to what's considered a dry use application, or dry use moisture content, which for lumber is 19% or less. For kiln dried after treatment KDAT, the kiln temperatures cannot exceed the kiln temperatures that would be used for untreated material. Because again, temperature is pretty critical here, and remember the FRT treatments reduce the temperature that combustion starts in the wood, so reduce the combustion temperature of the wood. So again, that's why some of the limits for how much or how high the temperature is when you're redrying the material back down to after it's been treated. There's also requirements in the code that talk about fasteners connectors in contact with preservative treated and fire retardant treated wood. 2304 10.5.3 talks about fasteners for fire retardant treated wood that's used basically in exterior applications, and there you basically have to go with some type of a protection, or stainless steel, silicon bronze, or copper. And you know, that protection is typically in the way of a hot dipped zinc coated galvanized steel. And if you're using connector plates, then those in terms have to be mechanically, or you're allowed to use mechanically deposited zinc coated steel. Now, typically for interior applications, you don't have to do any, or you need to refer to the chemical manufacturer, the treating company's recommendations. And if they don't have any, well, then the code kicks you back to 10.5.3 and using some type of a galvanized steel, or, like I said, stainless steel, silicon bronze, or copper. There's additional information in the National Design Specification for wood construction that basically includes in Chapter 2 for fire retardant treatment reductions for the material itself, and then also in Chapter 11 for connections. And basically the effects of, and this is reiterating what's in the building code, the effects of fire retardant chemical treatment on strength shall be accounted for in the design. Adjusted design values for the material or the connections have to be obtained from the company providing the treatment and redrying service. And with FRT, they can be very brittle, and so the fire-retardant treated wood should really never be used in applications where the load duration factor would exceed 1.6. So definitely don't want to use it, say, in impact type of applications or where the material could be subject to impact loads. For metal plate connected wood trusses, there's also additional information that's provided in ANSI TPI 1, which is the design standard for metal plate connected wood trusses, which is a referenced standard in the building code. And again, it talks about the requirements for the identification. The lumber that's used in the trusses must be identified by a quality mark of an approved inspection agency, identified by a label affixed to the package. The FRT lumber used in trusses shall be redryed after treatment to 19% maximum moisture content at temperatures not to exceed 160 degrees. Now, the trusses are not manufactured and then shipped off to the treater. Typically, the truss manufacturer is going to have to, they're probably not going to stock fire-retardant treated lumber in their inventory, so what they'd have to do is send material or obtain material and then design the trusses with that treated material. And so the material they're using has to be no more than 19% moisture content. The metal connector plates then also, what the grip values are, lateral resistance values or the plate grip values for biting into the wood, those reductions have to be as specified by the chemical manufacturer, and again, the quality mark shall indicate the design value adjustments are in accordance with either the FRT manufacturer specifications or based on approved methods which are included in the building code. So just to reiterate, both NDS and ANSI TPI 1 are clear that applicable adjustments, if you're using FRT for the lumber, those adjustments to the design values have to be provided by the material supplier. And all FRTW material suppliers typically do provide those reductions. Got a report that I'm looking at here from Hoover, ESR 1791, that has tables in it that list the various reductions based on climate zone and for different species. And so it's that information that is going to be used to be applied to the design values for the lumber to reduce those values to take into account the effects of the treating. And again, some of those properties that are typically affected would be compression parallel to grain, horizontal shear, tension parallel to grain, bending, modulus of elasticity, bending strength, and fasteners and connectors. So, specific to trusses, if a job is specified that requires the fire retardant treatment to be, or fire retardant treated lumber to be used in the trusses, the building designer is responsible for determining if the trusses need to be designed and built with fire retardant treated wood. Okay, section, chapter 2 of TPI 1 is typically referred to as the design responsibilities chapter, and section 2.3.2.4, paragraph G6.3 of that requires that the construction documents include information concerning moisture, corrosive chemicals, and gases expected to result in corrosion potential from wood treatments or other sources that can be detrimental to the trusses. So, assuming that information is included in the construction documents, then typically what the recommendation is the truss manufacturer and their design department would contact the truss design engineer and or the metal connector plate supplier, who typically is the one that has whose software, the design software that they're using. And they ideally would discuss the truss application and treatment being specified before bidding the job. This allows a truss design engineer and or plate supplier to determine the design criteria and connector plate type to use to design the trusses. Now, keeping in mind we're talking about trusses and the connector plates. However, if additional protection is required to the plates, there's a good chance it's also going to be required for other steel components or all the steel components that may come in contact with the trusses, such as nails, hangers, straps, that type of thing. And typically, hopefully this would be specified in the construction documents, but there are many truss manufacturers that help, or they also sell and provide the hangers and the straps, and so we want to make sure that that information is getting out into the field. Exterior exposures with metal plate connected wood trusses should typically be avoided. It's not that they can't, the trusses certainly can be designed for those applications. The concern is when you get into exterior applications, there's a continuous wetting and drying that's taking place of the wood. Wood's a biological material, so as it gets wet, it's going to expand or swell, and then as it dries, it shrinks. And the problem is that you have a continuous wetting and drying, continuous swelling and shrinkage, and eventually that could help loosen the connector plates. Since most of the connector plates used today, the tooth length is only about 3/8 of an inch to 7/16 in length. So that's why exterior exposures really are not a very good idea with metal plate connected wood trusses. A couple more items here and I'm done. Additional information, okay, if the project specifications require the use of a specific treatment, but after discussing with the truss design engineer or the plate supplier, it's decided we'd like to go with a different, well then obviously the truss manufacturer needs to consult with the customer and the building designer for review and approval of any treatment substitution. Adjustments to the design properties of the lumber and the connector plates to account for the type of treatment and design conditions are typically applied utilizing an inventory of the treated lumber that's already in the design program. However, it can also be manually applied by adjusting the durational load factors, or typically is applied by adjusting the durational load factors of the lumber and lateral resistance values for the plates. The best way to do that, again, for the truss designer is to discuss these procedures with the truss design engineer and the plate and software provider. It's recommended that the truss manufacturer also provide material safety data sheets for the treated lumber with each truss shipment so that the installers know what the type of product they're working with and any other safety information that needs to be they may want to take into account when they're handling this material. So finally, in concluding, fire-retardant-treated materials can be incorporated into buildings to reduce the ability of lumber products to contribute to a fire. The IBC requirements dictate where and under what circumstances fire-retardant materials are allowed. When designing trusses with fire-retardant lumber, ANSI TPI 1 should be followed as a guide for the appropriate drying conditions for the lumber after treatment, and then in addition, appropriate design value reductions for the lumber or connector plates should be taken following the FRT manufacturer's specifications. And with that, does anybody have any questions or comments?